question here from Unit 1, Section 3, Lesson 1, Graphing Rational Functions, Part 1. And you give the directions, and it says define the end behavior based on positive and negative numbers. In other words, I don't need to multiply those out. Graph will be positive or negative. And I want to make sure, well, I'm not 100% certain what you're asking about because I don't see that on slide 7, but just in general, I have a couple graphs here that were in the lesson. End behavior means what's happening as x gets, so we have two things we need to think about. What happens as x gets really, really negative, and what happens as x gets really, really positive. And that's all controlled by the horizontal asymptote. So in this case, and we see that by most of the time, starting by comparing the numerator and denominator. Since the degree of the numerator is x squared and the degree of the denominator is x squared, we're going to have, when the, I think I have this up to show you the rules again. Where did I put the rules here? Nope. I thought I had all of these in the, there we go, this is what I'm looking for. So we're talking about the end behavior, we're talking about looking at the degree. So when the degree of the numerator, n, is the same as the degree of the denominator, m, then we're going to look at the leading coefficients. And when the degree of the numerator is less than the degree of the denominator, then y equals 0 is there. So you're looking at, this one is the same, right? So this is why we're looking at the ratio. That's why 1/2. This is 1/2, and that's guiding the end behavior. So as x approaches negative infinity, y is approaching 1/2, and as x approaches positive infinity, y is 1/2. So the horizontal asymptote is what's going to guide your end behavior. But I think the second part of your question was asking about how do we know, because you were talking about these positive and negative signs. So this is asking what happens as it approaches the vertical asymptote. It can either, as it gets closer and closer to the vertical asymptote, it can be really, really negative, or as it's approaching a vertical asymptote, it can get really, really positive. And that's where, these are two different graphs, but that's where I don't have the sign chart on this one, but I do here, is we can see, as this is saying, as x is approaching -5 from the left, we can use this sign chart to say, oh, there's 3 negatives here, this is going towards negative infinity, and we don't have to know the exact values, we just know as this is approaching, this vertical asymptote is dropping. And since it's doing the same thing on the other side, is it's approaching -5 from the right, so it's coming here, as it gets closer, it also has a negative, it's going to be going down. So the sign chart is to help us find what the graph is doing near the vertical asymptotes, and the end behavior is describing what happens as it goes out. We can use one of these little sign charts to help us find what's happening at the vertical asymptote, and we can use the rules of the looking at the ratio of the degree of the numerator to denominator to help us find the end behavior. If this doesn't answer your question, please let me know and I'll try again.